All right, so I think I'm recording. Let's take a look at this problem. They want us to solve this quadratic equation. 11r squared minus 5r minus 22 is equal to 0. And they've been pretty generous. They're telling us to use the quadratic formula. Now, maybe they're telling us that just because that's what they want us to do, but maybe they've told us that because you can't factor this expression, and maybe they didn't want us to waste time trying to factor it. And that's what I think is going to happen here, because if we look at all the choices, we have irrational numbers in each choice, and when you can factor it, you'll get you'll get rational numbers. X equals 2 or x equals -5, or maybe those are fractions, but you won't have any square roots in your answer. So you've done the quadratic formula enough that you want to first make sure that this is in standard form. You have to have this set equal to 0. And the next thing you want is the exponents in descending order, 2, 1, and the constant. So I'm ready to identify A, B, and C. A is equal to 11, B is equal to -5, and C is equal to -22. We do that because we have a formula that they typically give to us in terms of A, B, and C. And this is the solution. This formula provides us the solution to this equation, and it has a title that they call it the quadratic formula. It's a fraction, and students are not in love with fractions, but the denominator is not that bad. You just take whatever the value of A is and you double it. You multiply it by 2. So our denominator is going to be 22, and that was pretty easy to see. The numerator, since you have an exponent of 2, there's actually two answers to this. And the two answers are so similar to each other, they only differ in whether you're adding the two numbers in the numerator together or you're subtracting them. Just to save space, they usually write it as plus or minus. Here I'm just going to, I'm going to write it as plus or minus, but when I'm actually substituting in, I'm going to break it up into two numbers, and you'll see why. The first term here is the opposite of b, and the next term is the square root, and underneath that square root is an interesting thing that's called the discriminant. And a lot of times, if you find this number first, it will help you in solving this formula, maybe save you some time. All right, so let's do that. Let's find that discriminant first. Let's take our own advice. B squared minus 4 times A times C, because we're going to have to do it anyway. B squared, hey, that's -5 squared. If you're using a calculator, you want to make sure that you have parentheses around that base. Then minus 4 times A times C. All right, so the -5 squared is 25, and we're going to add whatever. I've got a calculator here. At home, I do not have an on-screen calculator like I do at school. So I get 968, and because this was the two negatives here, that's why I wrote it as positive 968. And if we add 25 to that, we get 993. Now, in a multiple choice test, we can already see that B is going to be the answer because it's the only one that has a discriminant of 993. But let's go ahead and prove that these are the answers to this equation. All right. So take the opposite of B. The opposite of -5 is +5. And I'm going to do the addition first of these two. So I'm going to have plus, I've got my square root, and I've already done the discriminant. I've already figured out what this number is. It's 993. And that's being divided by 2 times A. 2 times 11 is 22. Or we have the x is equal to, with the subtraction, 5 minus the square root of the discriminant divided by 22. Now, oftentimes you'll have to look at this 993 a little bit closer and see if you can simplify this radical. I see 993 and I know it's divisible by 3, and I've got 331. But I don't believe that I can really reduce this 331 any further, so I don't think I can simplify this radical 993, and I'm not even going to try anymore because, like I say, I already see that among these choices, this is going to be the one that we pick. But if I didn't have multiple choice, um, I would spend a little bit more time in making sure that I can't break down this 331, but I think that's a prime number. Hope this helps, and I will talk to you later. Bye.